All right, so here we go. In this one, we have let y of t represent the population of a town over a 20-year period, where y is a differentiable function of t. That's important. The table below shows the population recorded. It should say recorded. I forgot to change it. Recorded at selected times. Yep, recorder. What up? So we're going to use the data from the table to find an approximation for y prime of 12 and explain the meaning of it in terms of the population of the town. Show the computations that lead to your answer.
Well, already I don't know what to do.
So that's why we're starting this one together, so you have a model for all the other ones you're going to do. So we're trying to figure out approximate y prime. Well, I have y of t right here. I have t up here. Y prime of t would be the derivative of y, but I don't have that. But I can approximate it by doing a secant line, or the slope between 2 points nearby. Well, what 2 points are nearby t equals 12? Exactly, 10 and 13.
What would the derivative even represent in this word puzzle?
Yeah.
Well, let's think about that. Let's do the calculation, and as we do the calculation, that might help.
Okay.
All right. So to approximate y prime of 12, and again, this isn't the only approximation, but this will probably be the best approximation because we picked the two things closest to y equals 12, or to t equals 12. So to do that, I'm going to say y prime of 12 is about equal to y of 13 minus y of 10 over 13 minus 10.
Mine looks
My first y looked terrible. My second y looked better. So if I start plugging in the numbers I have, I get 3,697. Woo!
Oh my gosh, I literally look like a 4-year-old.
Over 3 years.
Is it people per year?
Yeah,
Oh my god,
That's-
I spelled people wrong.
That's the derivative.
that's what the derivative will represent.
Oh, so the derivative is just the slope, kind of?
Yep.
Really?
Yep.
Derivative slope at a point.
Could you find
Piss.
could you find the slope of any tabular data this way?
Yeah.
So we've been doing it the hardest way our whole lives, when you could just find the derivative and.
Well, no, what we're doing, we're approximating the derivative.
Derivative
yeah.
is slope at
So-
a point.
I've had this scenario multiple times on different things.
On your stupid test, you never told us how to do it. I was gonna look up the answer.
But oh yeah, probably.
Made me angry.
That's probably very reasonable. But also a lot of some of the things we've used, yeah, whatever. You're right. But we're intentionally showing it to you now. I'm pointing it out because this is typically something that shows up multiple times in the AP test, a couple times in the multiple choice, and at least once in the free response. So if I've been negligent, now I'm retconning it and going back. All right. Retcon, make up for it, I guess. I'm just gonna say make up, maybe not retcon. Anyways, so that's how I'm doing my calculation.
196 and 130.
So it's 196 and 1/3.
Except for I don't know if I typed in the first number right.
No, that's right. That's fine. Yeah.
So people per year. So let's see if we've answered the full question. We came up with an approximation for y prime of 12. We haven't explained the meaning of y prime of 12 yet. In terms of population in the town, we showed the computation. So we've done 2 of the 3 things. We've done the approximation, we've shown the computations, but now we need to explain the meaning. So to explain this, I would say at year 12, the population
Oh my gosh, this is awful.
is growing at a rate of 196 1/3 people per year.
Mr. Wise.
Yo,
Should we keep it at 196 and 1/3? Or because like they always used to say,
Can't have
well, you
more-
can't have 1/3 people, so you have to round.
nah, just leave it. It's
You
fine.
can't have one third of a person either.
Yeah, so I was chop off like 4 of my.
All right. I didn't check the chat. Let me I think I answered this, but let me go back. The derivative is just the slope at a point. That's how we defined it. It's the slope at a point. It's the slope of the tangent line at a point. When we don't have that point, we can approximate the slope at a point using the slope at 2 points, which is how we built up derivatives in pre-calc. Is we started with doing the slope between 2 points really close together, and then we eventually figured out a method to find the slope at a single point. So that's what the derivative is. Again, it's just the derivative is a slope at a point. Yeah, it's a slope at a point, but if you don't have the point to find the slope at, or an equation for that matter, then you can do that in some other ways.
Wow, that's just crazy.
The virtual folks, did that help?
Mr. Wise,
Sorry.
It's all good.
yes, I'm gonna send him this morning, but I don't know what's going on.
Sweet.
I know what you did, like,
All right, folks, let's move on to part B. We're gonna see how much we get through. My hope is to get through all 6, 1 through 3, parts A and B for both of them, but we'll see. All right, part B. So use the data from the table and a trapezoidal approximation with 4 subintervals to approximate the average population of the town over the 20-year period.
Am I being stupid saying we add up and divide by 5?
Okay, hold on. Let me finish reading and I'll answer your questions. Show the computations that lead to your answer. So trapezoidal approximation means that we're going to find the area of 4 trapezoids to approximate the area under y of t.
So you gotta add up the 2500 and 2724 and then
Divide by-
divide by 2.
Yep.
Oh, that's so much work.
So here's what we're going to do. I'm going to do it.
Just find the area of the
Yep.
Gross.
So the first one first trapezoid I'm going to do is from t equals 0 to t equals 4. So to do that trapezoidal approximation, I'm going to say, I'm going to do 2, 7, 2, 4. I'm averaging them. Yeah, average. Divided by 2 times the width of the interval, which is 4.
Can you just put the 4 on the top?
If I multiply them all by 4, that's fine. I'm just leaving it like that to show the setup.
Okay, I'm special on the quickies.
It's all good. For the second interval, we're going to go from t equals 4 to t equals 10. The silly mistake that I make and a lot of you make is that to say, oh, the width of this interval is 10. It's not. What is it?
6.
Yeah.
That's so exciting for us.
Oh my gosh.
You're doing everything. Why was I gonna say the width is 13? Like, what am I doing?
Because that's what I do often and most of you do
No, but
as
not for the
well.
one with 13, for the one we're talking about.
Oh, then IDK.
To be fair,
All right. So then we'll do this interval.
is there a shortcut way to write this?
Not really.
So why is it always 2 on the bottom?
Because it's
Oh,
the,
because it's 2.
Yep.
Sorry.
Because when you add the 2 bases together, you're allowed to go
Multiply by
one and
0.5 as well.
You can also multiply by 0.5. Yeah.
Trapezoid.
There's probably 3 commonly used formulas for the area of a trapezoid, and they're all equivalent. I use this one I don't know, I just use this one. But yeah, you just multiply by 0.5 and you're already multiplying by 4 and it's all good.
I remember when they were trying to tell us why this worked, I literally did not get it. I said, you're being stupid. So many people.
Got it.
No, you gotta figure it out.
I'm trying to remember what we did in algebra.
know how you have to be good at math, don't try to understand why anything works.
Yeah.
But no,
questions
please do that.
gonna do it.
That's way better. 10 minus 13 minus 10 is 3.
Yeah.
No, it's 4.
Damn, so close. All right, and then here's our last interval.
You know what I mean? Like, everyone like, they just confuse themselves, they try to understand.
Like I always ask,
Confusion's good.
I asked where math comes from, and I don't know what teacher it was that tried to explain it, and I just like totally turned off. Like
I just turned off.
I had not had, like,
I'm the opposite of turn off, I turned
Then
down
I
on
asked
that
this
one.
lady, and she like, I don't know, I just. What?
One time Miss Clayton gave me a whole pass because I was late,
I don't remember.
that was clutch.
What'd you do, Josiah?
And Miss Clayton gave me, I was hanging up surveys and a little society, I was like, I said, Miss Clayton, she goes, oh, fine, because we'll make it happen.
She liked me a lot,
Me
because
too.
I remember I convinced her to let us watch the MLB playoffs during class, cause like, when you hit a bat, like you can find, I don't know, like when you hit a
Purples
bat.
or Bravos?
Yeah, I was like, she like totally allowed us to watch it.
Miss Clayton liked our class, I think she also really wanted to cry during her class.
Well, we did 7 hours, Jessica.
I know we did, I remember.
That was a fun class.
Yeah.
I hated that.
Okay,
Were you in that class as well?
Yeah.
I'm doing the calculations too.
alright, so then what do we do with the numbers that we get?
Once you've got all 4 of those colored number approximate or those numbers, add them up, see what you get. We're gonna write that number down and we'll talk about the next part because we're not done. The dividing by 2, by the way, for virtual folks, so the question was asked, why are we dividing by 2? Because for the area of a trapezoid, basically what we do is we take the 2 bases, the 2 values, and we average them. So that plus that divided by 2 gives us a height that we use. Or if that's kind of confusing, it's just the formula for the area of a trapezoid. No worries. We all can forget things are trapezoid sometimes. All right, so here's the number I got when I added this all up.
I bet it's all right.
Tell me.
I got 66,072.5.
Hold up.
Hold up.
That's what I got.
That far yet.
I didn't actually add it up, so I probably shouldn't say
Yeah,
that.
I'm gonna.
I learned.
I can make sure that I did my number right. So I did it all on one giant calculation. For your benefits, I would probably do each thing individually to show the work. Just make sure you don't goof it up throwing it all in the calculator.
Yeah, I was just learning the rest.
I did also.
I'm not smarter than the rest of you. I just do things. I've done it enough that I recognize the patterns.
More big brain.
I can take a big. I'll take a big brain approach on this. That's fine. I'll accept that. I'll accept that.
I take a tiny brain approach to everything I do.
Read.
I get 66,081?
Why did I get?
You just had, there was just a family that immigrated to the city after Mr. Watts finished adding.
Truth.
You're fine.
Damn.
can just
You had
say-
81.
Yeah.
Ooh, interesting.
Well, actually, let's just put it this way. There are some triplets born, all right?
A couple of pairs of sets of triplets, apparently.
No. 66,081. Yeah, right?
Yeah.
Yeah, see, someone just had some triplets after you did your calculation, so she's good. Okay.
Oh no, I definitely put a number in wrong.
I was gonna say, I didn't get anywhere near those numbers. I got a way smaller number.
Well, apparently Tyler is nowhere near him. Tyler's always right annoyingly. For whatever reason.
I'm not.
Oh yeah, I got it. I put in 2721 for one of them and it threw it off.
That'll get
So
you.
what's your final answer?
So
Make sure you say what is before it doesn't count.
I got 66,081.5.
Yep.
And you're adding, so you're calculating each section and then you're getting a number and then you're adding those numbers all up.
yeah, but we're not done yet. That's just that's what that is.
You're getting 60, what?
Please excuse my dear Aunt Sally.
So when you do that, again, make sure when you add those numbers together, you add them together and then make sure there's the parentheses around it, then multiply by 4 and divide by 2.
Never sign you off as a kid.
Oh my god, when Coach Garrett was like, yep, that's enough. I'm like, what?
Bro, when she said boy in the group chat, I literally lost it.
Oi.
I was
Like, what?
You want to see what I put in the calculator?
Wait.
Here, you should, so like,
Your setup is good.
oh,
Wait.
Plus.
oh, those are pluses?
Those are pluses.
Oh.
What? Silly goose.
Yeah,
Come on,
definitely
okay,
plus.
That'll change your,
That'll change it.
That'll change your outcome a little bit.
that'll change it.
A little bit.
Please excuse my dear.
All right.
son.
Well, I mean,
I'm
yeah.
gonna move.
all right. So as we are fixing that, make sure it's all addition. There's no subtraction in this.
Yeah.
This is the total area. This is the approximate area, the trapezoidal approximation of the area underneath y of t.
People per mile.
That's not everything we need. We want to try and find the average population. Well, y of t is
Divide by
the
20.
population. Yes.
Oh my gosh.
Because we need to divide by 20, because this is technically, if you looked at the units on this would be people years.
People years.
Because
Divide by years to get people.
exactly, because if you look at it, the 2,724 plus 250, those are people, so you're adding people together, dividing by 2, and then multiplying by 4 years. If you keep the unit analysis in there, it's people years. But that's a nonsensical unit, kind of. But for most applications, it's a nonsensical unit. And we don't want that. We want just the amount of people. So if we divide by 20 years, that will give us the average population of the town over the 20 years.
I got the answer.
What'd you get?
3304.06.
Point zero six.
I got 0.075. That's what I got.
Okay, so I rounded wrong and badly. So over and
Oh, Justin, how's your Goldilocks stuff doing?
awful.
Yeah.
But I short something, so that's good.
Oh.
What number did you get?
I don't want to say it.
3,304.075.
3,304.
9, Mr. Last.
Yeah.
Or is that a 5?
That's a 5 that I am bad at.
That's like
Mm,
not that common.
that's what you do when you get something on your test wrong and you're like, your teacher is like, what'd you write? You're like, oh.
The right answer.
Yes.
What's the decimal?
Yeah, what was the decimal?
0.075.
Point
It's
0.07.
just the wrong one.
5.
Oh. You know, that happens to the best of us.
It happens that way.
Yeah, it does.
Sometimes we just add when we meant to, or subtract when we meant to add, you know.
Yeah, sometimes you just do that.
Sometimes we forget how to add.
To be fair, that does
That's
happen.
what the cat test.
It's not my
All right.
fault, okay?
So folks, so we just did 2 different things in this first problem. The first problem, part A, was doing like some derivative stuff. The second part was doing some integral stuff. Because again, finding areas, dealing with integrals. We just did an approximation. That's that.
Also, so part B was just finding the total number of people in T or Y prime to 12, basically, or T12.
No, so part B didn't do that. What part B was saying is like, well, I can see the town population was changing. What was the average population of the town over that time?
Oh.
And so what we did is we added up the population
Oh.
the entire time and then divided by the years.
What would that piece of data even help you with though? Because like,
The average population.
Yeah.
yeah,
Generally the average isn't super helpful.
because if it's constantly growing, it's not gonna like.
No, it's because I just think we open it and then you like start talking.
No, and when it comes like for measures of central data, mean is probably the least helpful.
Yeah.
It's a little more helpful when you have continuous data though. And that's what this is more continuous data. And it's harder to find
Yeah.
that. And that's what calculus allows us to do is at least find that.
No more box plots.
Yeah, I mean, your box plot essentially is this graph.
Yeah.
If you were able to graph this.
This is what's stupid. The freaking median, they're like, line up all the numbers. Why can't you just put them in order for me? Okay?
Yep.
They're like, because we need to learn how to apply it. Yeah, so I'm like, why can't I do this one?
Why can't people figure out their own problems for themselves?
No, here's the thing.
Because there's money in figuring it out for
Yeah,
everybody.
I got
I just
so
don't-
upset when the.
They're like, well, you need to make sure you understand all parts of the problem. Like what? Counting? Like we're in 5th grade. I can count.
When I didn't know how
I
to
don't
do a problem for CPM, I was like, she wants to buy this amount of brownies, but she only has this much. And I'm like, why can't you figure it out yourself, okay?
You just give them the money, they give you some brownies, and you got it. No, here's all. forget a mode. I don't care what happens the most often. Then what's a node? Does it
Joey
matter?
Joey has 80 brownies. Joey eats 70. What does Joey have?
Diabetes. Joey has.
And missing a leg.
Also, they included relevant information. They're like, Timmy's going to the apple shop, and Timmy doesn't have any lice. But how many apples can you buy? And you're like, okay. Or they're like, this electrician has 24 watermelons. Like, and I'm like, what does that matter? Like,
Why do you?
Also, like, we don't do that, but yeah, you're right. Like, that does show up in
relevant
something.
information, and I go, okay.
Access information is kind of nice because it helps you start figuring out, like, what's important, what's not.
Tessa, hey, shut up.
First or last, it's a four pencil.
Read. All right.
Not the Riemann sum.
Not the remix.
Wait, you just did a Riemann sum.
That was a Riemann sum?
Basically,
That was a
Riemann's-
trapezoid.
yeah, but Riemann sum just means use a rectangle.
Oh, okay.
It's the remix.
So how do you do the midpoint? I know how to do the left and the right.
Right. The midpoint, not right, mid.
I don't think we went through the left or the midpoint.
Oh, midpoint's stupid. You have to do the left and the right and then average it, and that's how you get one.
Oh, really?
That's how you normally do it. Now with the tabular data, it's less complicated.
Is it? Okay.
That's why I was hating midpoint, so.
Yep. Okay. So let's see how far we can get on this one.
Okay.
So, 2. The rate at which water flows into a tank in gallons per hour is given by a positive continuous function r of time t. The nice. The table below shows the rate of selected values of t for a 12-hour period. There you go. So we have time and then r of t, which is a rate, gallons per hour. So we're going to use a midpoint Riemann sum with 3 subintervals to approximate this integral.
So is the derivative just gonna be gallons then?
The derivative would be gallons per hour per
Are
hour,
we finding that even?
not in part A.
Damn.
But the integral of r of t is going to give us only gallons.
Yeah, because the hours cancel.
Yeah, because gallons per hour times hours gives you gallons. But gallons per hour divided by hours gives you gallons per hour hour, which is like acceleration of the rate.
Take it back.
All right. So let's do this says to use a midpoint Riemann sum with 3 subintervals. So here are the 3 subintervals. We have this big old thing. And we need to use midpoints. So I think my first one is going to be here. My second one is going to be here.
Okay, get glasses.
My third one's going to be
I
here.
agree to that.
And they said get redone.
There's a lot of conversations that apparently should happen. But anyways, moving on. So here's how we're setting this up. We have 3 different intervals we can make so that there's a point in the middle of it, a midpoint,
Oh, you did that so smart, sir.
kind of. No, it was just because Google colors are red, green. It was just the order I went. I wish I could say that I did. That was not intentional. So we want to do a midpoint Riemann sum. So to do that, now one of the things that's very helpful on these is to actually say the integral that you're approximating.
That's a good one.
Until I wrecked
You
it.
just ruined
I
it.
totally ruined it.
Back arrow. I see it. It's right there.
No. Oh.
Yes.
You better.
Oh, that's so nice. You guys draw from the top or bottom?
Bottom.
Always,
Okay.
always from the bottom, because then when you do the integral, you evaluate it from the bottom to the
You
top.
said that and I tried to do it, but it looks like a lie.
It looks better
Rip.
when I do it from bottom to
Like,
top.
no.
Looks gooder?
I get a really, really excessively long bottom tail.
Yeah, I heard that.
It's
I
like a
didn't
U
say
with
that.
like a little like hook.
You
on it.
totally did.
Yeah, you did.
I said gooder?
I heard gooder.
I
did
thought I
too.
said better.
Idiot.
I
know.
heard gooder. And I heard him say gooder.
All right. All right. Focus. Get in. All right. So use this midpoint Riemann sum with 3 intervals. Okay. So in this first one, what I'm going to do is I'm going to use 13.4 times 4, because that 13.4 is the midpoint value of that interval. For the yellow,
There's so many noises.
my midpoint value is 14.3.
Oops, I forgot the one.
And I'm going to times this by 4. again, just to make sure I'm not going too fast on that,
Why isn't it 8?
4 to 8,
Why don't you multiply by 8?
because the width of the interval is just 4.
Oh, silly.
See, when I mentioned that, like I do that a lot, I've made the mistake and people have caught me enough that I just make the mistake much less now. And the more we talk about it, the better we see that like we all make those mistakes. Tricks are for kids.
I don't understand that. Tricks can be for anyone who wants them.
It really
Stop
can't be.
gatekeeping tricks. Alright, that's what it is.
Ooh, fair play. So there we go. Here's how we can set up this approximation. All right. So there it is. So now doing this, do you want me to show the numbers for each one? Rather than just do it as one giant thing?
Yeah.
Ah. I literally just typed in 14.8. I'm like, that's not helpful.
You're trying your best.
I'd like to think I am, but I'm not always sure that I am.
That's my thing. I was like, well, at least you tried. And I go, yeah, sure. Alright.
Sometimes I get imposter syndrome and like, am I actually trying my hardest? Like, I think I am, but sometimes I'm not sure I am.
I think you should
Ah, wrong color.
follow your heart. My heart tells me to stop doing a lot of things I don't listen to. But that's a me problem. That is a problem.
Oh, change color again.
Oh, I got a good number. That makes me feel confident.
What'd you get?
Ooh, what's that?
Oh, same.
Yes. Oh, when you work through that math out, you get like 2 pi.
How much was it?
That's probably right.
170?
I should add them this time.
I got 198.
That's,
Oh,
doesn't seem right.
Pretty sure you have a hole in your tank or something.
Oh, I found why.
Why's that?
I have a 6 instead of a 4.
Oh my gosh.
Hold up, I got 182.3.
So you want to talk about imposter syndrome? No,
I got
way.
170.
They're listening. They're listening. They're listening.
My grandparents think that they're like.
Oh, because I
listens to them.
was a dummy.
So,
And like,
You're in
this is
degree.
my grandma's Facebook, I'll look like
Right?
ads, and it's like, they're listening to me. I'm like,
I literally just got an Instagram that says, so you want to talk about imposter syndrome?
Oh, there it is. So 170 is the numerical value. Let's finish this part up. Now the unit on this, as we mentioned, was gallons.
GG's.
Okay, so what does this mean? Explain the meaning of this.
Gallons or 1 or 2?
Explain the meaning of this definite integral.
2.
Gallons. Like gallons are with an L.
This definite integral
This definite.
represents the amount of water that flowed into the tank I'm running out of room, so I'm going to abbreviate over the 12 hours. By abbreviate, I mean move it around so it kind of worked.
I don't understand why sentences in math feel so much longer. Like I write one sentence in math and it like takes me like 20 minutes.
Because the technical words we're using in there, you don't write them very often. So when we actually use those technical words, it feels like it takes forever. Yeah.
When we had to do those math problems, you had to explain your answer.
Oh my
No,
God.
in middle school,
Yeah.
do you remember the one that nobody could it was like the freaking volume one?
Back when he went to the school.
Liam was so
Yeah,
smart.
he was.
He
He couldn't do it.
just did so.
All right.
No, literally, she's like, we need to finish that one, took every, like literally her room, like people were sitting on the floor.
Okay.
No one could do the stupid ass volume.
Let's hit this one and we're gonna call it a day.
Let's do it.
I know I'm taking like all your time today, folks, but I'm trying to just give you this so you're like, when we look at the other ones, you can reference this.
You can get off.
We do 3 together tomorrow.
That's my plan. I'll probably give you folks the physical packet so you can start working on the stuff if you want to, but we'll do 3 tomorrow.
Sweet.
And then the rest of tomorrow will be work time on that, and at least Wednesday and probably Thursday at least, working on the pack, and we'll see where people are at.
Okay.
Thank you so much, Mr. West.
You're welcome.
You giving me class time right now? Like, I'm gonna be honest, I probably will not do anything outside of class anymore.
Last month.
Yeah.
I'm out.
Okay, so speaking of getting something done in class, let's finish up this one and we'll roll out. So a model for the rate of the water flow is given by that function where the positive rate P is measured. Okay, a model for that is measured in gallons per hour and the time T in hours. Use P of T to find the average rate of water flow during the 12-hour period. Indicate units of measure. Okay, so P is a rate. We want to find the average water flow, average rate of water flow during the 12 hours. Okay. So let's think about what we have and what we want. That's, I think, something that's gonna be helpful here because I feel like there's a lot of words, and as I read it, I'm like, I'm getting twisted up with the words. So let's try to think about what we have and what we want, which is also a very helpful thing to think about. So we know R of T was a rate. But what about P of T? Is P of T a rate, an amount, or a change in a rate? Well, looking at it here, I think it's a rate because it says the rate of water flow.
Yeah, I think it's a rate.
That'd be pretty smart of you.
So we have a rate. What do we want?
What is? Oh.
We want to use P
Good.
average rate.
Yeah.
Right?
Yep.
Find the
I'm
average.
so excited for this.
Okay. It's important to identify what you have and what you want because the calculations you do to get that are different. Like if P of T was the amount of water in the tank, we had an amount and we wanted an average rate, then we just do a slope between 2 points and call it a day. But if we have a rate and we want an average rate,
You have to put in count every single one.
right, which means we need to do an integral
Yep.
and then divide by the interval. Do an integral with a G and divide by the interval with a V.
So can you do that in 2 separate steps? Can you calculate out the integral and then divide it by the interval?
Yes, but you should like show the setup.
Okay.
So like for the setup, we're gonna do from 0 to 12. And I'm just gonna write P of T for the moment. dt. And I'm gonna multiply by 1/12, which is effectively dividing by 12. I don't have a good answer about why we don't just say divide the whole thing by 12. I think it's typically that we put it out front because dividing by 12 is really just multiplying. Multiplying and addition have simpler rules to use than division and subtraction do, so that's why we do that. Okay, this is technically a non-calculated problem. So in theory, we should be going through that and then plug in 0 and 12 and go from there. I'm not going to do that right now because we have about not much time left. So I'm just going to plug this in my calculator and find out what it is.
Okay.
Seem fair?
Yeah.
But since this is, I didn't tell you this was a non-calculator problem. If it gives you something like this and it looks like you should try to do it by hand if it looks reasonable to do it by hand. But if not, plug in your calculator and go. All right, so I'm gonna do this in the calculator real quick. So P of T was 1 divided by 60 times 750 plus 24T minus T squared. And for the record, in my calculator, I'm not using T, I'm just using X because, well, that's what I'm doing. I'm putting it into my variable calculator. So now I'm doing 1 divided by 12 times the integral from 0 to 12 of P of T with respect to X. So I'm just typing in that expression that I put up there.
Dividing by 12 basically, with the integral set as 0 to 12.
Yep,
That's it?
that's it.
Wow, that's cool.
It takes a little more work when you do it by hand,
Oh, I'm sure.
but I mean, it's a polynomial, so it's not it's not like you have to remember a whole bunch of wild rules. But this is going to give us 14.1. Oh, we have to include units, indicate units of measure. So this would be gallons an hour.
That's it.
Yep.
Yo, this is simple.
All right.
I'm gonna go home and do it again, because I won't get it.
Yeah.
And that's why we're doing this one together, so that you have this sheet as this is your reference sheet to be going back and looking at.
Yeah, I like that. I like reference sheets.
Reference sheets are good, they're helpful.
And because we're reviewing concepts while learning stuff and figuring out what we don't know and remembering what we do. That's part of the reason we're doing this. What's that? Oh, yeah. Virtual folks, we'll see you tomorrow if you're in person. Otherwise, virtual folks, we'll see you again. We'll see you all tomorrow in some capacity. If you're in person, you'll get some papers from me. Again, all the stuff's up online. So have a nice day. We'll see you later.
Bye. They can like heroes.
Yes, very much. I tested the microphone and me talking at my normal volume picks up perfectly fine from that point.
Well, that's
Like it did turn on noise dampening a little while ago.
So,
Yeah.
I turned in all these.
Well, I've done zero grading over grading.
Oh, Chris,
Do you think you can grade
the
them?
week before.
Oh, I tried it or whatever. I think it's through Friday.
Cool.
Thursday?
No way.
Yeah. I'm working on it.
Is it still third? I just wanna make sure that like you got.
Oh, yeah. As long as it shows up in your school sheet, I got it.
Okay.
And then it came back negative. And then I got-
Yeah,
Came in and we're like, wow, you would have thought.
I didn't expect you to be grading over grade.
Yeah, I didn't want to scare you.
I